Assalamualaikum warahmatullahi wabarakatuh and very good day to my FYP2 panels. My name is KHAIRUL NIZAM bin SAPARIN. I am doing my FYP2 titled Insulation Characterization of C4F7N CO2 gas mixture by HVDC to replace greenhouse sulfur hexafluoride SF6 gas usage. I am supervised by Dr. Ziraimi bin Aziz and I am using Console Multiphysics 5.5 software. Okay, for now let's look into the Console Multiphysics 5.5 software. To simulate a test HVDC test in this software, we need to choose the proper file to start. So for this HVDC insulator test, I use 3D and choose DC for stationary. So this part is the design geometry, which the upper part is the metal electrode and the lower part is the metal electrode, and the middle part is filled with the gas that we choose. So the important part of this is the material that we choose in the geometry. So like I said just now, the upper part is copper electrode and the middle is filled with sulfur hexafluoride. So the surrounding of this structure is set to be vacuum so that no current will be conducted outside of this structure and we can get a proper result. So for the copper, it has properties like shown here. We need to include the permeability, electric conductivity, and there's many here. For SF6 gas is a gas is not a familiar gas that available in this software, so we need to register as a new gas in the family of air. So we need to include instead the value of relative permittivity, electrical conductivity, thermal conductivity, heat capacity, and density. All the data should be inserted here so that we can fill this part with hexafluoride, sulfur hexafluoride gas. So for the result, to run the test, for the first part, I choose to analyze the electric potential that this structure experience, which I set this upper part to be very negative potential, and the lower part is very high potential, up to 2 times exponent 5 volt. So we can see from the color grading the positive potential decreasing to the negative part of the electrode. Then for the next 3D plot group, I choose to observe the electric field that experienced by the gas. So as I said, this part, the upper electrode and the lower electrode is a metal conductor. So a pure conductor should have zero electric field as shown here, and the gas insulator should achieve the maximum electric field, which up to 2 exponent 7 volt per meter, and no leakage of electric field should happen in this electrode configuration. So we need to plot the graph of electric potential. So as we can see here, from the positive potential decrease to negative potential. And next, also we can plot the graph for electric field from the metal conductor. The same process happened to the mixture of gas, the other mixture of gas, which is C4F7 and CO2 gas, that we replace SF6 gas here by insert all the values of material. The same metal electrode is used for the upper and the lower part of this comfort. For the last part, I use 20% of C4F7 and CO2 gas mixture to be tested in the gas volume. So I insert all the properties of this gas mixture into the material properties part so that we can test the gas here and plot all the graph needed. So those are the steps I take to model and simulate in the console multiphysics 5.5 software for isolation characterization of C4F7 and CO2 gas mixture by HVDC to replace greenhouse sulfur hexafluoride SF6 gas usage. So that's all. Thank you.